Hello there, StudyBuds. Welcome aboard the StudyWorld. This is your StudyBud MIDI. For today's trip, we're going to explore the world of physics. In this video, we're going to talk about mechanics as a subbranch of physics, motion and its types, a differentiation between scalar and vector quantities, and also between distance and displacement. But before that, you may look around and observe. There is motion everywhere, from the movement of our body to movement of a running car, and to more complex matters such as the birth of stars, galaxies, and other astronomical matter in the universe. Have you ever wondered why it occurs and how it works? Physics has the answer to that curiosity. Physics is a science that deals with nature, matter, motion, and energy, and their interactions. Going back to ancient times, Greek thinkers' interest in building a machine became one of the root foundations of technological development. The invention of the lever had eventually progressed over time to much more advanced discoveries. Physics has therefore played a significant role in technological progress. Physics use logical methods and mathematics to describe and calculate certain phenomena. For example, why is the sky blue? It will lead you to explore and understand electromagnetic waves, wave-particle duality, and the energy levels of atoms. Physics basically provides complex explanations to natural phenomena and even to simple events we didn't even bother to mind. But before we seek for answers behind those complexities, let us focus first on the very basic knowledge that we must know. Motion. What is motion? It might seem self-explanatory, but here's the definition. Motion is the action or state of moving or changing location or position of an object. There is motion when you move your body parts, when you walk or run, or whenever the object is moved by another person. The area of physics that deals with the study of motion, force, and energy is called mechanics. Mechanics is divided into subdisciplines, namely kinematics, dynamics, and statics. Kinematics is the branch of mechanics that deals with objects in motion without considering the forces affecting it. It only describes the motion and changes it undergoes. It can be expressed by using diagrams, numbers, and equations to create a model for representation and explanation. The term is derived from the word kinesis, which means motion. This can be applied when you determine the acceleration of a car with a given time and distance. Dynamics is the branch of mechanics that deals with objects in motion, considering the forces that can affect its motions. In the 16th century, Galileo Galilei was the first to recognize that force is the cause of changes in the velocity of an object before Isaac Newton formulated the laws of motion in the 17th century. A sample situation to this is when you determine the acceleration and direction of a parachute which was released in the air, considering factors such as its initial velocity, the time passed since it was released, the weight of the skydiver, and the upward force acting on it. Statics is the branch of mechanics that deals with objects at rest and forces with absence of acceleration and presence of equilibrium. Equilibrium is attained when the forces that act upon an object is in balance. Derived from the term itself, the word static means stationary or at rest. A body at rest means that the sum of all forces exerted on the body is zero. It does not necessarily mean that there is no force acting on the body. There are several types of motion: linear motion, rotational motion, and oscillatory motion. Linear motion. Linear motion is a motion in one dimension that moves in a straight line. Newton's law of inertia supports this. It states that an object with not the net force working on it will remain at rest or continue to travel along a straight line with constant speed. An example of this is a moving train. Rotational motion. Rotational motion allows continuity in magnitude and direction, which is impossible in linear movement. It is anything that moves in a circular manner. An example of this is the rotation of the Earth. Oscillatory motion. Oscillatory motion is the motion that acts back and forth and to and fro from its fixed position. An example of an object that depicts oscillatory motion is a pendulum. In order to describe and specify the motion, the speed and direction of motion is needed. A direction can be specified by north, east, south, and west, and also by up and down. A set of coordinate axes is drawn to represent a frame of reference. A frame of reference is a set of coordinates that is used to determine positions. Position is a location of an object with respect to some reference frame. It is given by the coordinates of x. 0 is usually set as the origin point. The x and y axes are always perpendicular to each other. The x-axis is often chosen as the line where motion takes place. However, if the motion is vertical, the y-axis is used. In order to measure motion, first the question how far the object has traveled must be answered. This can be explained by distance and displacement. What is distance? Distance is how much ground is covered by an object, regardless of its starting or ending position. There is no directional component to a distance measurement, making it a scalar quantity. Scalar quantities are quantities that are described by magnitude. Examples are volume, density, speed, mass, and time. In physics, distance is denoted as d. It may also refer to the physical length depending on some criteria. For example, in a 3K fun run, you ran a total of 3 kilometers. It doesn't matter where the starting line or finish line were, or in which direction you were running. It only matters that you covered a distance of 3 kilometers if you race and measure your path. Distance from x to y is also the same distance from y to x. The distance you covered from the starting line to the finish line is the same distance you covered if you start from the finish line to the starting line. However, some may confuse it with displacement. Displacement, on the other hand, is an object's change in position considering its starting position and final position. Its measurement does not take into account what route the object took to change its position, but only the position where it started and ended. The easiest way to picture out displacement is by locating a starting point and drawing a straight arrow from this point to the point where the object will stop moving. This arrow is called a vector. Its length corresponds to the magnitude of the movement, and the arrow points correspond to the direction of travel. This makes displacement a vector quantity. Vector quantity has both magnitude and direction. Examples are displacement, force, acceleration, and velocity. Displacement is referred to as a variable x, or as delta x. Delta is a Greek letter shaped like a triangle, and it's used to represent change in. Delta x stands for a change in location. So, displacement equals final position minus initial position equals change in position. For example, if you were riding a bicycle which has traveled 350 kilometers east, and then you go back 100 kilometers west to visit your relative, what is the total displacement of your travel? The displacement is 250 kilometers towards east. Distance versus displacement. To see the distinction between total distance and displacement, imagine a person walking 70 miles to the east, and then turning around and walking back west a distance of 30 meters. Total distance traveled is 100 meters, but the displacement is only 40 meters, since the person is now only 40 meters from the starting point. And that's it for today's video. Give this video a thumbs up if you learned something, and subscribe to this channel for more updates. Till our next trip to StudyWorld, StudyBuds.